It's no revelation to regular readers of Skeptophilia that I'm fascinated with quantum physics. A while back, I was in the car with my younger son, then about 17, and we were discussing the many worlds interpretation and the Copenhagen interpretation of the collapse of the wave function, as one does. And he said something that led to my writing my time travel novel, Lock and Key. What if there was somewhere that kept track of all of the possible things that could have happened? And thus was born the foul-mouthed, Kurt Cobain-worshipping head librarian of the Library of Possibilities, Archibald Fisher. The many worlds interpretation, which surmises that every time there's a quantum process that could have two or more outcomes, the universe splits, has always fascinated me. On the other hand, so many of its predictions seem to be untestable. It seems to fall into the category that Wolfgang Pauli called, "it's not even wrong." It's not falsifiable, because every time those splits occur, the two new universes are walled off from each other. They're unable to interact in any way, so there's no way to tell. This hasn't stopped science fiction writers like myself from capitalizing on the idea of jumping from one universe to a parallel one. This trope has been the basis of the plot lines of at least a dozen Star Trek episodes. Poor Geordi LaForge was always having to repair rips in the time-space continuum. So it was with great fascination that I read an article by physicist Sean Carroll that looks about what would it be like for our universe if the many worlds interpretation is true. It analyzes the whole thing based on quantum mechanics. Carroll writes, "Keep in mind the importance of treating individuals on different branches of the wave function as distinct persons, even if they descended from the same individual in the past. There is an important asymmetry between how we think about our future versus our past in many worlds, which ultimately can be attributed to the low entropy condition of our early universe. Any one individual can trace their lives backwards in a unique person, but going forward in time, we will branch into multiple people. There is not one future self that is picked out as really you, and it's equally true that there is no one person constituted by all of those future individuals. They are separate, as much as identical twins are distinct people despite descending from a single zygote. We might care about what happens to the versions of ourselves who live on other branches, but it's not sensible to think of them as us." Carroll's point is, if you buy the many worlds interpretation, should we concern ourselves with the consequences of our decisions? After all, if everything that could happen does happen in some universe or another, then the net result of our decision-making is exactly zero. If, in this universe, you decide to rob a bank, and in the alternate parallel universe your counterpart decides not to, that's exactly the same outcome as if you decided not to rob the bank and your counterpart decided to go through with it. But as Carroll points out, even if it makes no difference if you take into account all possible universes, it does matter in this branch. So it certainly has consequences for the branch you're in, as well as constricting your choices in later decisions. If you'd like to play a little bit with the idea of many worlds, there's an app you can get for your iPhones called Universe Splitter that allows you to make your decisions based on a quantum process. Carroll's example is if you can't decide whether to have pepperoni or sausage on your pizza tonight, you pose the question to Universe Splitter. The app then sends a message to a lab in Switzerland where a photon is put through a beam splitter with detectors on either side. If the photon goes to the right, you get pepperoni. If it goes to the left, you get sausage. So here, as with the famous Schrödinger's cat thought experiment, if the decision is based on a purely quantum process that involves the collapse of a wave function, your decision of what pizza topping to have and the means with which you decided split the universe in two. But what I wonder is, even if you use Universe Splitter, all you've done is put the decision off one step, because then you still have to decide whether to abide by the decision that you got back from Switzerland. You've split the universe into an abide by the decision branch and a don't abide by the decision branch. How many of us have decided to allow the flip of a coin to make the decision for us, and then when the coin comes up, we decide, I don't like that, and flip the coin again? What's always bothered me about many worlds is it's kind of an embarrassment of riches. If every time a process could go one of two ways, then very rapidly the universe splits so many times there's an infinite number of them. Physicists tend to be rightly suspicious of infinities, and that's why a lot of them are dubious about many worlds. I completely glossed over this point in Lock and Key and pretended that the number of decisions was finite and countable, and so you could have a library cataloging all of them. That may be the biggest whopper I've ever told in any of my novels. And that's coming from a speculative fiction writer. Playing around with the rules of the universe is kind of my stock in trade. Carroll seems fully aware of how bizarre the many worlds model is, but he still seems to favor it over the seemingly arbitrary Copenhagen interpretation. He says, and this quote seems as fitting a place to stop as any, "Even for the most battle-hardened quantum physicist, one must admit that this sounds ludicrous, but it's the most straightforward reading of our best understanding of quantum mechanics. The question naturally arises, what should we do about it? If the real world is truly this radically different from the world of our everyday experience, does this have any implications for how we live our lives? Largely, no. To each individual on some branch of the wave function, life goes on just as if they lived in a single world with truly stochastic quantum events. As counterintuitive as many worlds might seem, at the end of the day, it doesn't really change how we should go through our lives." If you enjoyed this video, please give us a thumbs up. Our resources are down there, and please subscribe to our channel. Thank you.